word of introduction. Everything I'm going to say is entirely subjective. So you are most welcome to disagree, de gustibus non est disputandum. Who I am? I happen to work here. I've been writing Erlang code for 10 years or so, and I still love it. Who am I not? I'm not a theorist. I'm not a mathematician. I don't know any sophisticated typing theories. So if you, after this talk, have an urge to discuss some abstract concepts, you probably will find right people in this room, but this is definitely not going to be me. I'm just a pro who needs good tools to do his job. So I'm sometimes trying new ones, which sort of contradicts point one, but there we are. So I tried Gleam. Gleam is a friendly language for building type-safe system that scale. That's a very good marketing. The most important thing about Gleam is that it's built on top of the Beam. If it were not, we won't be talking about it here. It is a bit like Elixir in a sense that it compiles down to the Beam. It is unlike Elixir in a sense that Elixir compiles down to AST, while Gleam compiles to Erlang, and then Erlang machinery toolset takes it on. So you can read the Erlang code and see what's going on there. And it makes it a bit easier to mix the pure Erlang and Gleam-generated Erlang together. It also compiles to JavaScript, because why not? I was told by the organizers that making snarky remarks about JavaScript is not considered appropriate anymore, so I won't elaborate on that. It just does. So how does it look like then? This is how it looks like.
Oh, like Java.
Like what?
Like Java.
Nope. A bit maybe like Elixir, not like Erlang, which is a disappointment for me because for all the weird syntax I got used to it. But it's kind of pretty. I mean, if you are going to start something for 8 hours a day or more, it better look good. So I hope it does. Now, the syntax there's pretty much everything you would expect. I'm not going to go through it in detail because that's not the point of this meeting. What are the things that struck me as new or odd or unusual, good or bad? It has pipes, which we still sadly miss in Erlang, which are a honking great idea, beautiful. It has partial application, which is and a bit more, because normally partial application means that you have a function which has 2 arguments, you call it with 1, and what you get back is a function that accepts the other one, because the first one is already bound. So here it is taken a little bit further, because you can choose which argument you are going to bind and which you left open for access. So this is really cool, especially if you are building complicated pipes and you need lots of it. What then? Variables are assigned by a let instruction, and you can reassign variable. Why? Why? One of the coolest things in Erlang is that you cannot do this. Once your variable is bound in the scope, end of story. It's not going to ever change in this scope. And here you can reassign. I know in Elixir you can too, but I hate it. Sorry. There are code blocks, which you can just put it in the curly brackets, and whatever you write in that block, in the code block, it's assigned to this value. It is a bit like Erlang's begin-end construct, but slightly better because begin-end does not scope values inside it, so they can leak out of the block. While here, if you assign a variable b some value, it does not exist here. So this is good. It makes code more orderly, more compact, and more safe. Something that I found really odd at the beginning was this. This is a simple case instruction, and this is fine. This works. But if I change it to something like this, it won't compile anymore, because case has to be exhaustive. It has to cater for all possible values. Which is like, why? Well, in Erlang, I would just say, okay, I know that it's going to be 7 or 8. If it is anything else, then the code just falls off the cliff, let it crash. So let it crash is no more in Gleam. This is a major paradigm shift. That part of philosophy is just thrown out of the window. The code is not supposed to crash at all. This is a bit of annoyance. And what's more, because it's typing constraint, there's no way to do something like, let's get back to this. Nope, this won't compile. I will get immediately bang. Because it has to return the same type. Because, and now we are going to all the typing magic. We have a function that adds something to an integer. And this is fine. But some of you are very familiar with you, some are probably not. Well, I was not. So that's why I'm sharing my experience. This won't compile, because this is an integer, this is a float. So the compiler figures out from what we are trying to do what type is going to be applicable here. And when it sees this, it says, OK, this function accepts integer and nothing else. So there's no notion of, yes.
Is it just limited to integer or number?
This is integer. This has to be integer.
I mean, technically.
Yeah, no, this is just an integer of any size.
Sorry, if you
yep.
want to do like 7.0?
This would work. This would be a float.
Yeah.
Because that's the compiler, you know. And it's the same goes for strings, atoms, all the basic types. So it's a bit like what dialyzer does, but dialyzer is slow, dialyzer throws errors that are not often very easy to interpret, to put it very mildly. And dialyzer uses compatible types. So because it's quite understandable, because in Erlang you can add integer to a float, but here you can because you cannot even try. The compiler won't let you. So because of this, and it has a lots of implications, because of this, we cannot do a list like this. Is it readable for all of you? Okay. Because a list have to be homogeneous. All items have to be of the same type, which is quite obvious, because if it were not, you wouldn't be able to. Yeah. Okay. You wouldn't be able to iterate over it with a function, because a function can access only a certain type. And it goes on and on from here.
Sorry?
Yes.
Go back, and does it complain about the name of the variable being the same as the name of the function?
Where?
There's a function called a, and there's a variable called a.
But they're in
It's a different scope,
right?
Well, there are different functions.
I mean,
No.
there's a variable in the C function as well as a function.
No, it doesn't.
Okay.
It will complain only about the wrong typing. I think I have to fix here, because I won't be able to give other examples otherwise. Yeah. And of course, there are many, many more elaborate types. So to cut it short, like we're sort of fast forward, here is a stupid example of a piece of code which uses all the typing, all the basic typing features. Like we have a type of breed of a dog, which can be setter, shepherd, or border collie. We have a type that's going to hold a name of a dog or a person, which is a string. So it's sort of type that holds another type inside it. And we can have composite types. And this is a bit like Erlang records or Elixir. We have a type called dog, and it has two fields, name and breed. And name is represented by this. Breed is represented by one of these. So if I want to print, I can instantiate them in a pretty straightforward way. I create a dog, which has a name. A name is Bob, and the breed is a setter. If I want to print a name, I can just use dot syntax, like for accessing Erlang record fields. If I want to print a breed, I can, of course, I have to, of course, cater for all possible values of the type breed, and I can print something out. And all this is checked at all times, and every function can accept only one type and nothing else. And this is so bloody annoying. I mean, because in Erlang, I can do something like this. It's so easy because there's a very simple workaround. I have a function that needs an integer. If it happens to be a binary, fine, I just add another function head, flip it, switch it to integer, and bang, there we go. No way. If I write a function in Gleam, I guess it works the same for any other strong typing languages, that accepts a given type, and it happens to be something else, that means that I got everything wrong. That I have to rethink all my typing architecture, all the structure, the whole call chain is just flowed, basically. So it's the first encounter with it, it's really very difficult and quite unnerving. And at some point, I had an epiphany, because I had a recollection. Do you remember physics classes from the high school? When you solved equations, like, I'll give you a simple example. When you are given acceleration and time, and you have to calculate distance traveled by a body. So you have acceleration, which is a, and it is meters over second square. You have a time, which is in seconds, and you are expected to calculate distance, which is going to be in meters. So you come up with solution, and the solution is a times t square over 2. Now, how did you check? Do you remember how did you check whether this is correct? You checked units of measure. So you write, okay, I have acceleration multiplied by time square and divided by something that's not typed, because just a figure. Bang, bang. What do we get? We get meters. Correct? Correct. So most of the mistakes you might have made would be immediately spotted here, because if you are supposed to calculate distance and you end up with something like this, then you probably got it wrong. Of course, if you did 3 instead of 2, that won't be spotted. You can't have everything. And this works exactly the same way here. Your function should come up with a certain unit or type. If they don't, it's wrong. If you added instead of subtracting, okay, sorry, that's flowing logic. But the typing was correct. And that helped me. That's why I thought, okay, this actually makes sense. There are more cool things you can do with it. Like, for example, because we don't let functions crash. So if a function, for some reason, cannot do what it was supposed to do, it has to return an error. So we have a type for it. It's a bit like in Erlang, you have a convention that you return either OK something or error something, the tuples. So this is pretty much the same thing, but more formalized. There is a type called result, and it's either an OK with a certain value or an error with a certain reason inside it. Which, by the way, and this is getting a little bit more abstractish, because this is called generic type, or I think it's parametric polymorphism or something. Basically, it's a type that can hold a value of any other type. And this is very important, which more of that in 5 minutes. So this is neat because you can do very cool things when it comes to piping with it. Because here we parse an integer, a string, and we expect to get an integer. And then we pipe it through the functions from using module code result. So this one, here we try, and we need a function that accepts an OK with a value and returns OK with a value or an error. And the map uses function that must not fail. It just always return a value. So it gets, when the OK travels up here, the value is extracted from the OK. Someone is knocking at the door, I think. And applied here, and this returns a value. And then we unwrap it and print it out. And if at any stage we get an error, then the rest is skipped, all the tries. So it's like the newly introduced maybe in Erlang. Erlang 26 introduced the concept of maybe, which is very similar, but this is more elaborate. And this is strongly typed and blah, blah, blah. So this is it. And now we haven't even touched on the most powerful thing in Erlang, which is messaging. And here is where the big troubles begins. Because we have this piece of Erlang code. It's absolutely trivial. We spawn a new process. It is wrong. It should have spawn instruction here. I forgot. Never mind. And then we send an integer to it, and then it's going to receive that integer and do something to it. Now, what's the problem with this code? What type is the M going to be? We have no idea, because we are in the wild. Anybody can send anything to it. Because this is just like a trash can, a big mailbox. You can just dump whatever you want and deal with it. Which is, of course, not acceptable because we are in Gleam. This is type language. So how does Gleam handle it? Gleam introduced the concept of a subject. So if a process wants to receive anything, it has to create a subject and select on this subject. So other process that wants to send something to it needs to know the subject. And so I am a process, I create a subject, and I wait. But that someone wants to send something to me. But that someone needs to know the subject. How? I have to send the subject. But how? And here we start going in circles. So to flip it backwards, step by step. First thing I do is I create a subject. And then I spawn a process, like a process called Nelson. I spawn Nelson and give him as an argument my subject on which I'm listening. Then Nelson creates a subject on which he's going to listen for integers, and using my subjects, sends it to me. And now we are good. So I can send integers to Nelson. Fine. Yeah. So how it looks in the code. This function is run by the main process. So it creates the subject, and subjects are, of course, typed. This is the most important thing. And this is the generic type. So this was what I mentioned earlier with the OKs. And I start another process, which is going to run this function and get my subject. So that other process creates its own for listening and waiting for integers, and sends it to me. And then having received successfully the subject, I can send something on it. So this is how it works. And this was the toughest part of my encounter with Gleam, because like, why? Jesus, it was so simple. It used to be like, I've been doing this for 10 years straight, and it was like, it was beautiful, simple. Why make it so complicated? Well, there's a price you pay for having a strong guarantee that it doesn't fail. It never goes wrong, because whatever you send, whatever you received, is guaranteed to have a type you expect. And it is being figured out by the compiler itself. So if I do, if I do something like this, I put some other type here. This won't even compile. So yeah, And this is all very good because if you get anything wrong, you don't have to run tests. You don't have to even compile, because if you have a good editor, it will flash a red flag here immediately once you finish typing.
Can you try to compile it?
Yeah, sure. Let me make some order here.
Why is your editor not underlining that?
Because it's obsolete, rubbish. Yep, there you go.
Now, what if that is done in multiple files?
The same.
I just don't get it. Sorry. how it can pick up the type from in another files? Like theoretically, it's compiling files one by one, not having the whole model of the types.
Don't ask me. So yeah, this was my my crash self-learning course with Gleam, and it involved a lot of hard work and a deteriorating vocabulary. Fortunately, no ladies were present at that time. Was it worth it? Definitely. Am I going to use it at work? I would like to, but that doesn't depend on me. Does depend on me.
Just don't tell the customer. It compiles to Erlang. Just say you wrote it by hand.
That's an idea, though.
Someone reviews it.
No problem.
That might be ethically like gray, so to
It's
speak.
easier to be forgiven than to get permission.
Yeah, you gave you something to think about.
It's recorded.
So I know there are other, because there's a big debate in Erlang world how to solve the typing problem. So this is one approach. I think there are other attempts, maybe more, maybe less successful, I don't know. So here is something for you. Now, as the old saying goes, put it in your pipe and smoke it, and maybe give it a try yourselves. That's it, thank you.
I think just a comment.
Yeah.
You know what a static type system or a strong type system does is it reduces the surface of attack of the software it's running, and so where I see an interesting Gleam is in the embedded space, where an IoT devices and microcontrollers and the likes, where you reduce basically the risk of the systems being hacked.
Yeah.
But doesn't it, like, if you compile it to Erlang, well, at the end of the day you're running Erlang, right? So if you...
Yeah, but you are, yes,
It
but
is runtime, right? You just show them.
Yeah,
but
it
the
is.
surface of attack is
They
still
communicate on the, like, they basically agree on the type, right? In runtime. It's not in
that's right.
Compile time you checked it, right? So you know it's right.
Yeah,
Period. I mean, you could say the same argument for any compilation, any strongly typed system, right? Because you're just going to compile it to assembly. That's not typed at all, right? So
because it's kind of like when you write the code, you have the assumptions, right? You know your typed messages, basically. But
Sorry, yes? Come again, please.
yeah, so like if you write like all the code, or
Yeah.
your company writes all the code,
Mhm.
you kind of agree on the type of messages, right?
Yeah.
And in the situation like when multiple companies' devices talk to each other, right?
Yeah.
Or some hackers' devices.
Yeah, I mean, if you enter a shell, then there's nothing that could stopping you from doing anything. It's just on the coding level that this gives you all the guarantees. I'm trying to. There it is.
seriously, so you could compile the Gleam, stick it in, run it like I don't know via Elixir, and it won't. You could fuck it up. Yeah.
Yep.
It doesn't stick a piece of logic between.
No, it's just a pure Erlang code underneath. So It gives you.
No, there's no runtime next to it. No runtime library.
No.
Okay.
If I understand your question, the answer is no. Yes.
Can you declare the types explicitly?
You can. Sometimes you have to, because you cannot change or force the type, but you can for documentation, and sometimes you have to. I had somewhere here a piece of code when I had to. Yeah, here. I don't exactly know why, but here I had to give an explicit type because the compiler couldn't figure out by itself what it's supposed to be.
Can you give it a type that's like an integer or an atom?
Sorry?
Can you give it a type that's like an integer or an atom and call it something?
Well,
Okay.
I guess if you violate it, I mean, if it doesn't work, it won't.
Can you have type unions?
Yeah, that's
Like this or this or this? No.
You have to do enums, right?
theory.
Yeah, you have to do enums. And yeah, please don't get into the theory. I just show you how it works, and this is pretty much it.
And well, it's pretty clean how to call some Gleam stuff from Erlang, but is there a way? What would we need to do if we want to call some Erlang code from Gleam?
Let me show you. I had some. Where was it? Give me. Oh yeah. This is a call to an Erlang code. So you have to define. Of course, you have to define a type that the value will become when returned, and you write a function to call it.
And what if the types are not correct on the runtime? Then you just wait.
At runtime,
Yeah.
like this.
Yeah. If you just lie there, if you say that, it will crash.
I mean,
when it doesn't
I can't exactly lie because I can name it, this is the name I came up with. I can name it,
Yeah, but
a
if you
bottle
say it
of.
returns integer, but it returns string, for example, and then you use it as an integer.
Oh God.
It will just crash.
Yeah.
On runtime or the compiler will.
You do it in some smart way, and you don't really do anything with the type. Just pass it to another Erlang function, which happens to work, which is basically the usual way in Erlang.
Frankly, I don't think you have the same level of guarantees when you're making external calls. So to some extent you're on your own. So, but like from now on, if you get this right, then from now on, when you're in Gleam space, then you are protected, so to speak.
Is code swapping supported?
Yeah. I mean, this is Erlang underneath, so you can do whatever you want. You can find out the.
I'm thinking that if you recompile a module and a type disappears because of the recompilation, then you reload it.
But then you lose all the guarantees, right?
Yeah, I mean, this is the. I spoke to Robert Wierding a couple of times about this, and he always said, "Well, typing in Erlang, well, it won't work because you can hot load code on the shell, and then all the guarantees are gone." But yes, but when I write code, they are there. But yeah, of course, because you can find it compiles one-to-one. So the channels Gleam generates channel L, and then underneath you have channels.ebin, and then in a shell you can call it and swap it with anything else. You can swap it with another module of the same time written in Elixir or Lua or whatever.
Does it support macros?
Not that I know of. Yes.
Do the type also, like the compile type types, do they also generate like guard clauses with the underlying Erlang?
Come again?
Like if you have a type, if you declare a type on a function and then you compile it onto Erlang, does that Erlang include a guard clause on that function?
Let's see. composite types. No. No, but it includes specs. So if you like, you can run dialyzer on it. If you have nothing better to do. Okay, we have one more speaker, so yes?
I just wanted to say one thing. I really like your analogy here.
Thank you.
And this, there's this whole debate, like some people really like types,
Mm-hmm.
and like they cannot write programs without types. And there's this group of people that said like, I don't need types because I have good tests, right?
Yeah.
And this is kind of about this. So like, if your units agree, it's the same as types agree. So basically like a sanity check, right? You did not do anything that's fundamentally wrong.
Yes.
But there's still like really important details, like this 3 or 2 or 1.5, right? And this is tests.
Yes. Exactly.
So like basically you probably need both.
Yes, absolutely. Yeah, because if you get the business logic wrong, then you have to test it. Yeah, of course. Okay. Thanks again.